So happy Friday.
Woohoo!
Woohoo, woohoo. How many weeks left?
3.
3, count them, 3 weeks left. We can do this.
Yay.
Okay. So, make yourself a little sketch of the unit circle. And I'm going to take some points off the unit circle that are going to be easy points to find. And I'm going to take the ones at the coordinates 1, 0, 0, 1, -1, 0, and 0, -1. And the function y equals sine, we're going to use as an argument for sine theta, the angle measure. And then the output of this function is going to be the sine of that angle measure. And that sine, remember, is the y coordinate of the xy coordinate. Okay. So what we will make ourselves a little xy table. Thank you. Listen, Ali. The inputs that I'll use will be, what is the angle measurement that's going to get me to the point 0, 1 right here? What's the angle measurement that's going to get me right here to the point 0, 1? I'm sorry, 1, 0. An angle measurement of 0 is going to get me to the point 1, 0. And what is the sine? What is the sine of that point? The y coordinate. So I should make that a theta. Make it a little more descriptive here. Theta and sine of theta. There we go. All right. Now let's look at the point on the unit circle 0, 1. What angle gets me to 0, 1? 90. And what is the sine of that point at 0, 1? It's the y part, 1. Okay? Now let's go over to the point -1, 0. And what angle gets me to -1, 0? 180. And what's the sine of that angle? The y coordinate of that point on the unit circle is the sine. 0. Okay? Then we get down to the point 0, -1. How big is that angle? 90, 180, 270. And what is the sine? -1. All the way back around to the 1, 0 point again. And I've gone how many degrees? 360. And what is the sine at that point? 0. So let me graph this function. My axes are scaled. Here's 90. Here's 180. Here's 270. Here's 360. My outputs go between 1 and -1. So there's 1. There's -1. I have 0, 0. I have 91. I have 180, comma 0. I have 270, -1, and 360, 0. And my function looks like one of those functions that we studied at the beginning of the chapter, the periodic function. And this one is called sine. All right. But we don't always do things in degrees. So let's look at the sine function. Oh, sorry. We'll look at the sine function using radians instead of degrees. So my inputs are still going to be theta, and my outputs are going to be the sine of theta. And I'm still going to go to those particular points because those are the easiest ones for me to see on my graph, the easiest ones for me to graph. And I'm going to go 0 radians, and that's still at the point 1, 0. So what's the sine of 0 radians? Okay. If I go up to the point 0, 1, how many radians have I gone? Pi over 2. What's the sine? If I go to the point -1, 0, how many radians have I gone? And what's the sine? And if I go to the point 0, -1, how many radians have I gone? So I've gone a half pi, then pi. Next mark is going to be 1.5 pi, 3 pi over 2. What's the sine? And then if I've gone all the way back around the circle and gotten to the point 1, 0 again, how many radians have I gone? And what's the sine? All right, I don't have to stop there. If I now get back up to the point 0, 1, and I've already gone around the circle once, I've gone half, 1, 1.5, 2, 2.5 pi radians. What's 2.5 in a decimal? What's 2.5 in a fraction? 5 over 2. So if I keep going around, I get back to the point 0, 1 at 2.5 pi radians, and the sine is 1. Let me get back to let me keep going and hit the point -1, 0 again. How many radians have I gone around the circle now? 3 pi. And that has a sine of 0. Now, let me start all over again. Start back at 1, 0 and go negative. Move around the circle in this direction. I have gone negative pi over 2 radians. And what's the sine? And if I continue to go in the negative direction and hit that -1, 0, how many radians have I gone? Negative pi. And the sine of that is 0. All right, so let me plot these points. Let's see, my tick marks on my graph. Here's pi over 2, here's pi. Here's 3